Okay, so in this video we're going to be discussing about resolution of forces. So we're going to resolve forces to its horizontal moment, vertical moment, and also find the resultant of those forces and also the angle between them. So but before that, let me refresh your mind on SOHCAHTOA. So let's say we have this, and then this is the horizontal components and the vertical components, and then we have let's say 8 Newton force here. So how do you find the horizontal component, which is F of x, and vertical component, which is F of y, of this force 8 Newton? So when I SOHCAHTOA, this is opposite, hypotenuse, this is adjacent and hypotenuse, and then this is opposite and adjacent. So for us to find the horizontal moment of this force, we are going to relate the hypotenuse of this right angle triangle to the adjacent. Keep in mind that hypotenuse is the line facing the angle 90, then opposite is the line facing the angle in question, and then the adjacent is the line connecting this angle 90 and the angle we are resolving to. So what's the relationship between this F of x and the resultant of this triangle? So remember, this is hypotenuse and this is adjacent. So if you come to this SOHCAHTOA, you have hypotenuse here and you have adjacent here. So their relationship is cosine. So let's say cosine 30 degrees is equals to, which is adjacent of our hypotenuse, and our adjacent here is F of x, then over hypotenuse, which is 8 Newton. So doing cross multiply, our F of x will be F of x is equals to 8 cosine 30 degrees. So what about F of y, which is the vertical component? So keep in mind, this is the opposite because it is facing the angle, and this is the hypotenuse because it is facing this angle 90, and then this line is the adjacent connecting the angle 90 and the angle we're resolving to. So we are looking at opposite and hypotenuse, which is this sign here. So we're going to have sine 30 degrees is equals to opposite, which is this F of y, over hypotenuse, which is this 8 Newton. So doing cross multiply, we have F of y is equals to 8 sine 30 degrees. So this is how to resolve this force into a horizontal vertical component. That's this one. Yeah, so let's go to the cases we have. So let's look at case 1. So case 1 is where we have this, let's say this is let's take 30 again, and this force is 3 Newton. Now case 1 is where we have this angle inclined on the horizontal axis, you understand? And then case 2, we'll be discussing about when it is inclined as the vertical axis. Let's use the same 3 Newton. So remember that the line that is connecting the angle is going to take the cosine of the angle, you understand? For example, now this line now that's connecting this 90 degrees angle and 30 degrees took cosine 30, and then the one facing this angle 30 took sine 30. So that's the same case here in this case 1, because this line here now is connecting this angle 30 and then sine angle 90 here. If we want to resolve this force, our horizontal component will take cosine theta. That's any force we see like this is going to take cosine theta. Let's say we have another force here that is 9 Newton and then inclined at angle 10 degrees. Remember, this thing is not drawn to scale. And we also have another one of 3 Newton inclined at angle 25 degrees, and then we also have another one of 4 Newton inclined at angle let's say 45 degrees. Now all the horizontal components of all these forces are going to be taking cosine theta. Reason is because all of them are inclined to the horizontal x-axis, and that horizontal x-axis formed the angle 90 degrees. It connected the angle 90 degrees and this angle 30 degrees in question. Now let's say that this one, we have this horizontal component here, and then this one is the vertical component. Remember, it will take sine. This vertical component will take sine because it's facing the angle we are resolving to. The same thing is applicable to this one here. This line here, which is the vertical component, is going to face, it's going to take the angle 25. This vertical component here is going to take the sine of 25 because that's the angle we are resolving to. And also this one here now also is going to take the sine of the angle we are resolving to because it is facing the angle we are resolving to. So this is the case 1. And then case 2 is where the angle is inclined at the vertical y-axis. So in this case, our horizontal component will take cosine of the angle, while our vertical component will take sine. The horizontal component is going to take sine 30, while the vertical component will take cosine 30. That's a mistake. Now, this vertical component will take cosine 30 because this vertical component has this 30 degrees and also the 90 degrees. Understand? And also this sine 30, this horizontal component will take sine 30 because it's the line facing the 30 degrees angle. So this is the case 1 and case 2. And also this case 1 now, remember we have something like this in mathematics. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now in this first quadrant, all the trigonometric ratio here are positive. Now in this case, S is positive, this one T is positive, and then this one C is positive. So in this case now, the cosine and theta and tan are all negative. In this quadrant, sine and cos are negative. In this quadrant, sine and tan are both negative. So in this quadrant now, we are going to be using this method also to be resolving the angle here now. But remember, I want to tell you something. If you want to resolve this angle here now, let me draw it out. So this is 9 Newton, and then this is 10 degrees, and this is our plane. So remember, the horizontal component of this force now is facing towards the negative x-axis, and hence the horizontal component of this force is going to take a negative sign. Now the vertical component of this force is going to the positive y-axis, and hence the vertical component of this force is going to take positive sign. So if we want to resolve this thing down to each horizontal and vertical component, we are going to have the horizontal component to be negative 9 cosine 10 degrees. Remember cosine because this is the line that is holding both the angle in question and the angle 90 degrees. And also with this I explain here, if you draw it out, you can resolve it using this way. So the vertical component is going to take positive sign, and it will be 9 sine 10 degrees, and then it's 9 because, and then the sign because this is the line that's facing the angle in question. So this is how it goes. And then if you want to, this is the one, this is quadrant 1. So and then in this thing here now, the sign here is positive, and hence we have positive sign here, and the cos is negative, and hence we have negative sign here. Understand? So let's do the one that is on the third quadrant. Let's pick this one. So this is it. This is 25 degrees, and then this force is 3 Newton. Now remember, the horizontal component of this force is going towards the negative y-axis, and hence the horizontal component will take negative sign, and then the vertical component also facing towards the negative y-axis will take a negative sign. So if you want to resolve this force now, remember this line now is the horizontal component. It has 90 degrees and this angle, so we are going to be having negative 3 cosine 25 degrees, and then the y axis, which is the vertical component, will be 3 sine 25 degrees. Now this is both negative signs because in this third quadrant both sine and cosine are negative. You see it. But for this thing to work, all your angles must incline on the horizontal axis. That's the horizontal x-axis. All your angle must incline on the horizontal axis. It won't work for this one. If you try this with this one, you are going to fail. So let's do this one that's on the fourth quadrant, which is this. So let's say we have this is 45 degrees, and then we have 4 Newton here. And because this angle is inclined on the horizontal x-axis, as on the x-axis, we are going to be having our the horizontal component will be cosine theta. So, and this horizontal component now is going towards the positive x-axis. So we'll be having positive 4 cosine 45 as our horizontal component, and then the vertical component of this force went down and it took the negative sign because it's going towards the negative y-axis. So we are going to be having negative 4 sine 45 as the f of y, and so this one will be f of x. So with these explanations, this is how to resolve forces to its vertical and horizontal components. So let's go and solve practice questions. So let's resolve this first to use horizontal component, vertical components, find the magnitude of the resultant force, and also the angle which the force, the horizontal force makes with the horizontal. So let's continue. These are horizontal force, and these are horizontal components and vertical components. So for 30 degrees, the horizontal component here is going to take the sine of the angle because the horizontal component is facing the angle. Understand? So, and then it's moving to the negative x-axis. So it's going to be negative 86 sine 30 degrees. And then our vertical component, which is this line here, is moving towards the positive y-axis. It's going to be, that is positive 86 Newton cosine 30 degrees. Now it took cosine of the angle because the vertical component has the 90 degrees angle and also the angle in question. So then let's work for this 40 degrees angle. So the horizontal component of this force, keep in mind, is going towards this direction, that's to the positive x-axis. So it's going to be positive, and then it will also take the horizontal component to take sine of the angle because that's the line facing the angle. So it's going to be plus 24 Newton sine 40 degrees, while the vertical component is going to take the cosine of the angle, which is 24 Newton cosine 40 degrees. So let's calculate all the horizontal components. So negative 86 sine 30 plus 24 sine 40 is going to give us negative 27.57 degrees. That's the total horizontal component. Then total vertical component is going to give us 86 cosine 30 degrees plus 24 cosine 40 degrees, and then we have 92.86 Newton. Now the resultant force is gotten by f of x square plus f of y square. That's using Pythagoras theorem. So it's like this because this, let me draw this Cartesian plane. So this is f of x and is negative, so it's going towards the negative x-axis. Remember, f of x is on horizontal axis while f of y is the vertical axis. So this negative is going towards the negative horizontal axis or negative x-axis, and then this is f of y is positive. Remember, this is negative, that's why it's coming towards this way, and then this is positive, it will be going towards this direction, and then which is positive. So this is the reference angle. This angle here now is the reference angle, but the angle we are going to find is the angle from this place to this place. That is, we are asked that the angle we are going to find is the angle from the positive x axis. So if you find this reference angle, our main angle will now be 180 minus this reference angle we are going to have, because from here to this place is 180. So 180 minus theta is going to give us our main angle. But then let's find theta first. So this is 27.57, and then this is 92. This is 92.86. So forget about the negative sign, because this negative sign is just for us to know the direction of the force, you understand? And then you have know the direction, and then so the resultant force is now going to be 27.57 square plus 92.86 square. I can put negative because just negative times negative is going to be positive, so it doesn't make any sense. So this is the resultant force is equals to the square root of, let's say, 27.57 square plus 92.86 square. So going to give us 9383.08. So our resultant force is now going to be square root of this. That's square root of our answer, which is equals to 96. It's equals to 96.86, or let's say 6 Newton. So this is our resultant force, and then the angle is gotten by tan theta is equals to f of y over f of x. Now see the reason. Remember, we are dealing with, this is adjacent and then opposite, and you know tower is opposite of adjacent, so we are going to write tan theta is equals to opposite, which is this tower, opposite, which is f of y. Remember, this is f of y and this is 19 Newton f of y, so this is, that's equals to f of y over adjacent, which is 27, which is f of x. Okay, so that's how we got this. So we're going to have tan theta equals to f of y, which is 90.86. Now don't worry about the negative sign for this 27, it doesn't matter, over 57 degrees. So it's going to give us 92.86 divided by 27.57, going to give us 3.368. So our theta is going to be equals to tan inverse of 3.368. So you have that our theta is equals to tan inverse of 3.368. We have 73.463 degrees. And so this is our reference angle. This 73.463 degrees is our reference angle. That is this angle here. But we're going to find the angle it made with the horizontal x-axis. So horizontal positive x-axis. So we're going to say that our angle theta is now equals to 180 minus 73.463. Then our theta is equals to 180 minus 73.463. That theta is equals to 106.54 degrees. So this is how to find the horizontal component, vertical component, the resultant of the forces, and then the angle between them. So by this, we're able to solve all the questions we come across on the resolution of forces to use horizontal and vertical components. But let's solve one more question. So let's solve this question. Let's solve this forces to use horizontal and vertical components via the resultant forces and then the angle between them. So let's continue. This is 4 Newton force, that's this 4 Newton force, and because this angle is inclined to the vertical axis, so this the horizontal axis, that is this axis, is going to take the sine of the angle because it's the component that is opposite the angle. So the horizontal component is going to be 4 sine 30 degrees, and the vertical component, which is this angle, and then remember it's going to be negative because it's going towards the negative x axis, and then this vertical component is going towards the negative y axis, so it's going to be negative 4 cosine 30 degrees. Now cosine because this is the line that has both the adjacent the angle 90 and then the angle in question. So for 10 Newton force, this 10 Newton force, the angle is inclined to the x-axis, and hence is going to take the horizontal component is going to take the cosine of the angle because this is the line that has both the angle and the 90 degrees, and then it's going towards the positive x-axis, so it's going to be positive 10 cosine 45 degrees, and then the vertical axis is going to be the vertical component will be positive too because it's going toward the positive x-axis, so it's going to be 10 sine 45 degrees. So for 8 Newton force, this 8 Newton force, this is the vertical component of the force, and it's going towards the negative y-axis, so it writes negative, and then it will take the sine of the angle because it's facing the angle, so this is negative 8 sine 30 degrees, and then the horizontal component is going to take positive because horizontal component is positive because it's going towards the positive x-axis, so you're going to be positive 8 cosine 30 degrees. And so the 5 Newton force, that's this force here now, so the vertical component is going to take the sine, which is sine 5 sine 60 degrees, and then the horizontal component is going to take the negative 5 cosine 60 degrees. So it's negative because this angle is going towards the negative x-axis, and then this one is positive because it's going towards the positive x-axis. So let's punch our calculator. So let's sum the horizontal forces, the horizontal components. So we have negative 4 sine 30 degrees plus 10 cosine 45 degrees minus 8 sine 30 degrees minus 5 cosine 60 degrees. So there's a mistake somewhere. This is cosine. Sorry for that. And then this one is sine. I was thinking self. So this is 8. The vertical component of this 8 Newton force is going to be sine. This is the vertical component. It's facing the angle, and then the horizontal component is going to be cosine. So you have 8 cosine 30. 8 cosine 30. And this will also be positive because it's going towards the positive x-axis. And then the vertical component is going to be negative as it's moving towards the negative x-axis. I think I was well that confused myself. So this is going to be positive. And then we have this as 9.499 Newton. And then let's calculate this and know what we're going to get. We have negative 4 cosine 30 degrees plus 10 sine 45 degrees minus 8 sine 30 degrees plus 5 sine 60 degrees. And then we have 3.94 Newton. So let's go ahead and find the resultant forces. So let's do this, the Cartesian plane. Remember, this is positive x-axis, so it's going to move this way up to 9.499 points, and then this is 3.94 Newton, and then it's positive, so it's going to move positive to y-axis. And then it happened that our reference angle is also our main angle here because it started from the horizontal x-axis. So we're going to, and this is 9.499, this is 3.94. So tan of the angle is equals to f of y, which is 3.94 over f of x, which is 9.499 Newton. So remember, this Newton will cancel. So our tan theta is going to be 3.944 divided by 9.499. So is equals to 0.4152. And theta is equals to tan inverse of 0.4152. And so we have that theta is equals to 22.55 degrees approximated. So our angle here is equals to, theta is equals to 22.55 degrees. And so let's find the resultant of the forces. We don't find the resultant, so let's do it here. So the resultant of the forces is equals to, we have 9.499 square plus 3.94 square. So our resultant force is going to be square root of 9.499 square plus 3.94 square. So is equals to square root of this 10.28. So resultant force is equal to the square root of this is going to give us 3.21 approximately newtons. So these are resultant force. Thank you for watching this video. Share this video. Have a nice day.